the average value of a function. Consider a continuous function, perhaps piecewise continuous, on the closed interval a to b. My claim is that there exists a value c on the open interval a to b such that f of c times b minus a equals the integral from a to b of f of x dx. Now, what does this mean? Looking at the left side, we see that f of c times b minus a is really like f times delta x. So the claim is that there is a single rectangle, and I'm going to pick a c value somewhere around here, maybe like this. It's going to hand draw it, such that if I find the height there, and draw this rectangle, then the area of that rectangle is equal to the area under the curve of f of x on the interval a to b. Now, my c value was not chosen perfectly. In fact, maybe if I move my c value over just a little bit to here, we can see that's a little bit better representation. That this area here is equal to the area under the curve. Well, this part is extra for the integral. This part's a little bit too little, but they cancel out. So I'm not trying to prove it to you. I'm just trying to convince you that this is a true statement. Because if that is a true statement, then we can say f of c equals what? Well, dividing both sides by b minus a, we get 1 over b minus a times the integral from a to b of f of x dx. And so f of c is called the average value of the function on the interval a to b. One way that helps me to remember this formula is by thinking about how do I find the average of anything. Let's say I have 10 numbers. How do I find the average? Well, you add up all the numbers and divide by the total that you have. Isn't this the same thing? Don't we add up all of our small values and then divide by the total length that we have? Well, that's an average value. Let's do a few examples. What if we want to find the average value? I'll abbreviate as AVG. So the average value of, let's say, f of x equals 3x squared plus 2x on the interval 0 to 2. How do we find the average value? Well, it's 1 over b minus a, so 1 over 2 minus 0, times the integral from 0 to 2 of our function. And then we can use the FTC and other things to evaluate this, like the constant rule and power rules. So we get 1/2 times what? Times the antiderivative, x cubed plus x squared, from 0 to 2. I will leave my 1/2 outside and do the FTC on the inner part, which says plug in the top limit, 8 plus 4, minus plug in the lower limit, 0, giving us 1/2 of 12, or 6. So the average value of f on that interval is 6. Another problem. Let's find the average velocity on the interval, say, pi over 2 to pi, where we're given the velocity, we'll call it v of t, equals cosine t minus sine t. How do we find the average of anything? Well, the average of anything is 1 over b minus a, end point on the limit minus start point on the limit, times the integral from a to b, pi over 2 to pi, of that anything. So the average value of anything is 1 over b minus a times the integral from a to b of that anything, which in this case is cosine of t minus sine t. Let's simplify this constant out front first. We get 1 over pi over 2, which is going to give us 2 over pi. Then times the integral of cosine, which is positive sine. And then the integral of negative sine is positive cosine, from pi over 2 to pi. Continuing on, we get 2 over pi. I like to leave my constants outside till I'm done almost always. Then we plug in the top limit. Sine of pi is 0. Cosine of pi is negative 1. And then minus, plug in the lower limit. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. And we get the value, negative 4 over pi. Let's do one more example, which might look a little bit more complicated. But we're going to see that we'll do it basically the same way. So find the average value of f of x on the interval 0 to 3. I'll write my interval this way, where f of x is defined as a piecewise function. Specifically, it equals x plus 1 from 0 to 2, and equals x squared from 2 to 3. How do we handle this? The exact same way. The average value of anything is 1 over b minus a times the integral from a to b of that anything. This is how we do it. The only problem, if there is a problem, is how do we integrate this part? So we'll leave the 1/3 outside. How do we integrate from 0 to 3 if f is defined piecewise? Well, we simply break it up. From 0 to 2, we know that f of x is x plus 1. And then from 2 to 3, f of x equals x squared. So it's really not that difficult of a problem. We'll finish it off. We have 1/3 on the outside, and then we integrate this first piece, x squared over 2 plus x on the interval from 0 to 2, plus x cubed over 3 on the interval from 2 to 3. Continuing on and continuing also, to leave the constant outside, we'll do the FTC part 1 on this first piece. We plug in the top limit, 2 squared over 2 plus 2 minus, plug in the lower limit of 0. And then plus, we'll do the FTC part 1 on this piece, which says plug in the top limit. 3 cubed over 3 is 9, minus, plug in the lower limit, 8/3. And then putting a few things together, we get 1/3, and then we get 13 minus 8/3 equals 1/3 times 39 minus 8/3 equals 31 over 9.